Good evening, everyone. So let's get real with NLP. Okay, so on today's agenda is we'll have a brief overview of NLP and some of its use cases. And for this session, I'll be going over a sample use case of question generation. And there'll be a demo as well where I go over the code on how we can achieve this task. And then we'll end it with a quick Q&A session. Yeah, without further ado, natural language processing. What is it? It's basically a machine's ability to understand text in the way that we humans do. And it's where linguistics, which is the study of language, and computer science, which is study of computers, where they coincide. And it's basically the computers try to understand both syntax and semantics of a language. So syntax is grammar and semantics is the meaning. So if you, for an example sentence, if you think of a sentence like the dog created a website, the grammar is fine, but semantically, the meaning, it doesn't really mean anything. So NLP tries to perfect this by understanding both of them, syntax and semantics. Some applications of NLP would be sentiment analysis. So this is where it's trying to understand the intent behind text. So whether it's like positive or negative, it's useful for like reviews and feedback. So we can understand quite easily what the reviews truly like what they mean, because and you can categorize it quite easily. Language translation. So we might think language translation is quite an easy task, but it's not only like a one-to-one translation. Different languages have different syntax, and the meanings can vary quite. Like there can be a big variation in meaning. So NLP helps us to translate it in a way that is both syntactically and semantically correct. Text summarization is shortening a body of text, selecting by either looking at the overall keywords or the topic of the whole body of text and preserving that and shortening its length. Email filtering is where we can categorize our emails as like promotional emails, whether it's forum, newsletter updates, or even spam. So this is by analyzing the content of the email, maybe the subject, and it tries to understand, okay, this belongs to this category, and so on and so forth. Yes, just a small PSA, like if you're a student and you're getting started with NLP, I highly recommend that you register for the GitHub Student Developer Pack. There's a great offer for a 3-month free trial at Data Camp, and they have some great courses there for NLP and other data science related courses. Yes, and yeah, question itself. So what is question generation? And it's the process of generating questions from a given source. It could be a knowledge base, text, images even. And the answer to the questions that are generated should be should be available from that source material. So we should be able to find it from there ideally. And yeah, why like question generation? What are the uses? So it can be used in educational like purposes. So we can convert like a textbook. We can take that text and make it into some sort of questions, and we can extend it to corporate use. So if you have any documentation that may require compliance of an employee, and you want to like gauge whether the employee has understood these documents, you can easily take some key points and convert it to a question and get the understanding through it. Yes. Types of questions. So these are some common types of questions that we see if we've all done exam papers, and we dread seeing these different types of questions: multiple choice, true, false, fill in the blank, WH questions, which are basically who, what, where, when, how. So these are the types of questions, and different question generation systems could generate a specific type or multiple types. And for this session, I'll be looking into type of a hybrid. It's like a fill in the blank multiple choice question, which we'll see later. So let me talk about the MCQ structure. So the main question or statement is known as the stem, and the incorrect options are distractors. So they are trying to throw off the person answering the question. And while the correct option is mostly known as the answer or the key. Yes. And some common steps. This is the general process when we're trying to generate MCQs. Text summarization. So as I mentioned earlier, an application of NLP basically by shortening the text, and ideally why we want to do this as our first point in question generation is it'll make it easier to process, because a big chunk of text would take like much time and resources to get through. So we want to summarize it while keeping that main idea there. And there are two ways that you can do this: is extractive summarization and abstractive summarization. So extractive, as shown in the slide here, is basically, as you can see on the right hand side, the sentences, you can find them exactly on the left hand side. So if we're taking exactly what's there, those main ideas, and keeping them in our shortened summary. However, abstractive is something that we humans tend to do. If you're passing on a message or telling a story, we tend to add our own words, and we tend to remove stuff. But that overall idea is there. So it makes the summarized content more interesting because it adds its own new content there. A bit more complex, but yeah, you get a different idea. Sorry, same idea. It's a different approach. Yes. Keyword and sentence selection. So now that we have our summarized content, we want to identify what are the keywords here. So we need these keywords that we're going to be taking them as the answer key for MCQs. And yes, so we need to identify out of our text what are the keywords, the ones which maybe appear quite often and have some sort of correlation to the overall theme. Yes, and when we are selecting sentences, not every sentence may be fit to be used as that stem, because they might be too short. So ideally, it would be good to use a lengthier sentence, and one that basically, if you in the slide, it's we can't use that first sentence. It doesn't really mean anything. Like it's ambiguous. We don't know what it could mean. And the second sentence, however, is quite good. There are some keywords as well in it, so that's an ideal sentence that we'll be looking. And keyword sentence mapping. So we want, this process is quite important because we want to keep track of our keywords and the sentences which they're in. So we just want to map it and keep it set so we can use it as we go on. So these are some keywords and the sentences which those keywords are consisted in, basically. Yes. Generating distractors, there are many ways to generate distractors, but I've gone with these three approaches. So a word net is basically, if you take a word, there are like a hierarchical trees there. So there may be something which a broader topic for that word, or maybe something more specific. So these are known as hypernyms and hyponyms. Quite confusing to say, but the idea is a hypernym is a broader topic. So in this case, purple, the broader topic would be, it's a color. And a hyponym is something more specific. So purple, underneath that, it could be, you could get more, even more specific with crimson, violet, lavender. So in this case, if our word was purple, what would be the best distractors to use? It would be the siblings, or what's the co-hyponyms. Those are quite good because they're not still under it. They're not too specific and not too general. So they're perfect and in that same level. Sense to vec. So sense to vec is it's like its own version of word to vec, kind of. So what word vectors are basically words would have it's like it's kind of like a data set that's been generated that would create a relationship between multiple words, and it'll have show how similar two words are, and they'll have like a distance in between them. Sense2vec was created through Reddit comments. So you may find some relationships which you may have not thought of before. So it's kind of creating these relationships through what's known in the internet. And similar entities. So as we process our text, they get labeled as an entity, certain words. So it could be a person's name, an organization, a date, or geolocation. So ideally, a bunch of words grouped as one label would be easy to use as distractors. So if in our group of entities, if we have geolocations and Sri Lanka is there, we might have Germany, Australia, and all, other countries. So we can easily use the same labeled words as distractors. The spaCy pipeline. So once you process your text through spaCy, which is going to be the library that would basically do much of the work throughout this session. You will see it later in the code, and I'll be going a little over the library itself. So it consists of these few steps. So tokenization is where it'll break our text into small tokens, smaller chunks, and parts of speech tagging is where it'll tag those individual tokens as, okay, whether it's a noun, a verb, an adjective. And dependency parsing is within a certain phrase or sentence, it would identify the relationship between each of those words. So is this the object to this word, or is it the subject? That type of relationship is identified through dependency parsing. Named entity recognition, as I mentioned earlier, the words could get labeled as entities. So whether it's an organization, a person, a date, a time, those sort of labels are identified in this step. Lemmatization is where basically trying to find the form of a word. So if we're thinking of presenting, that's the word, the base word would be present. So it's basically trying to remove those extra ings and eds, past tense, and continuous tenses to find the base form of that word. Yeah, now just getting a little into the libraries. So there are quite some libraries that I'll be using within the demo, and they all have they all serve their purpose. So I'd like to just quickly switch my screen. And yes, I hope y'all can see my screen. And yes, I'll get started with spaCy, our main package. So this library, as you can see, in this demo, this little documentation where they're passing this bunch of text, and spaCy breaks it down. They basically take like an object-oriented approach of like tagging each. It's not simple string manipulation here. So they tag it as, so it'll be, the whole thing would be called a document, and then there are sentences. The individual sentences will get tagged. The individual words are known as tokens, and if we're thinking of taking a few words, a phrase, maybe from the 0th index onwards to maybe the 4th or the 3rd, that'll be called a span. And once it's passed through the pipeline, you can do many things, like you can just run through the noun phrases, the verbs, and this is to go through all the entities within the document. And spaCy is quite robust, and it has really great performance. And I would say it's an out of the box NLP sort of solution. So if you're a beginner, it's really helpful and great. I found it quite great when I started out. But there are other packages which do what spaCy does, and NLTK is one of the most popular ones. And we are using it, but not to carry out the main functions. We're using it more as some support library to get access to different data sets. So in this case, as you can see, it gives you access to 50 corpora and lexical resources. So there might be a Twitter data set, or some sort of like different Reddit one, and you can access all of them through NLTK. There might be certain words that you want to omit from your pipeline. So those are like stop words, repetitive words which don't really do much. You can remove them through this. So NLTK is a great tool as well. However, it is similar to spaCy, but this is more, I would say the approach is more string manipulation. So you have to do, I think, a lot more, and it's not as out of the box with the object approach that spaCy does. Yes, the BERT extractive summarizer. Sorry, let me just Yes. So this is the library that I'll be using for the summarization part. And what's neat about this is you can specify, okay, I want ideally like 20% of it minimize, so that you can set like a ratio, the number of sentence you want, minimum and maximum length. That's really great. And there's another feature which is co-reference resolution. So if you have a sentence such as this: my sister has a dog, she loves him. But if you were to summarize this and the first sentence was lost and it's just she loves him, we don't know who she is, we don't know who him is. So that sort of resolution needs to be done, and that's handled as well within this library. Sense to vec. So this is the sense to vec like spin on that word to vec approach. So it's from Reddit, and the relationships between words have been found through that. And it's quite neat because there are some there's an online demo, and you can like type in different terms and you can see how the relationships have been found and formed, as opposed to word to vec. There are word to vec online demos as well, which you can go through, and you'll find that certain words which aren't in word to vec vocabulary can be found here. And spaCy WordNet. So this is a simple connector to add WordNet access to the pipeline. So in LTK, we download access the WordNet through NLTK's interface and connect it with this package. And this is the example as we saw earlier in that hierarchical tree. This is the WordNet online application where you can just search different words. You can find the more specific ones and the more broader terms for each word. So yeah, sorry, it's great. And flash text. So what flash text is being used for is to manage our keywords and our sentences. We can do this manually, like using regex. So you can say, okay, find this word within all our text, but it's going to have some performance issues, and I don't think it will be as optimized as it could be. So using flash text, we manage our keywords, and with that, we can easily find keywords within text or remove them and manipulate keywords. The Python key phrase extraction is what's being used to identify the keywords within the text. And there are various models that you can use and different approaches. So that it's listed here. There are unsupervised models, supervised models that you can just switch out and see which one works best for you, because certain models will rank your keywords differently and select, include and exclude different keywords as well. And PyWSD. So word sense disambiguation. This is basically if you have two words which are spelled the same but have different meanings. If you think of bat, you have your cricket bat and you have the animal bat. So to just differ and find which meaning is truly meant in a sentence, you use a package like this. So there are two ways of doing it with LESC algorithms. So a LESC algorithm is basically words which are commonly used together are considered to be in the same neighborhood, and LESC algorithm tries to find like the similarity to it. And the way it does it, for example, like with simple LESC, it looks at the definition of each of those words and checks the closeness of those words. And this sort of similarity is done with the closeness of I think it's similar to word vectors, and as well as the content of each word, so how it's used. Those two are some common approaches, and we'll be using both within the demo and seeing which one performs better and gets us that right word sense. Uh, yes, so we'll be heading into the demo. Let me just quickly share my slides again, and there'll be a QR code there, which you can access the Google Colab. Yes, so feel free to access the demo through this QR code, and I'll have to go back to my browser to share the demo. So pardon me. Yeah, hope all of y'all can see my screen. And yes, so first step is install those packages that we just went over. So download, these are some like helper libraries that I'm getting access through NLTK. Stop words is like, as I mentioned, some words like a, the, it. So some words that really don't contribute as much. And there are some other ones like WordNet. Um, and spaCy, you will need to download a language model. So spaCy has different sizes for each of these language models. I have the medium one. So this could affect your output like quite a lot, I'd say. So you'd find that the one with the largest set, you have more favorable results. However, it comes at the cost of resources and time. Yes, so this is downloading the Reddit sense to vec dataset. And so yeah, these once you run the Colab, it'll take some time to install all the packages, and you will then have to later import all the packages. And this is me. It's basically, this is our input file. It's a simple text file of the topic in this case is the Industrial Revolution. So it's a lot of text, and we'll be generating questions from it. Yes, the first part of text summarization. So there's a simple method here which uses the BERT extractive summarizer. I've given it some parameters, like we want a minimal length of 60, max length of 500, and around like 40% uh, of it. Yes, so this is just passing the text file through, reading it and summarizing it. That would also take some time as well. And as you can see, this is our summarized text. It's still long, but much shorter than the original. And then we get to the point of keyword and sentence selection. So I've made it so that you can pass the different model names, and then you can like just play around with it and see which one works well. Later on, we'll see a comparison of the outputs and like how much they differ. And yes, so this is we pass our text and which one we prefer to use, and we try to get some keywords out of it, some key phrases. So the top 10 key phrases would be extracted. And this is to another method to get the entities, the labeled entities from within our document, and we'll store them in a dictionary format, which is basically the text and the label for that text. So it'll be like Sri Lanka geolocation, something like that. Sentence selection. So we'd want to select sentences from our document and ideally have them be 20 characters of length, more than that. Those would be some ideal sentences to consider. So this is basically just the running of the above methods. And this would be some keywords that are found. So industrial revolution, as it's the common topic of the whole thing is industrial revolution. It identified that's a good keyword, and some other keywords are here. So as you can see, this is the entity labeling. So 18th century is labeled as a date. Britain is a geo, I think it's a geopolitical entity. I'm not too sure. I call it a geolocation, and there are another thing which is called, I think this is more of a bigger location. So it's not like an individual country per se. Yes, so these are the different keywords that are taken. So these are like keywords, overall keywords, keywords which in the text, and entities which were found. And these are sentences. So we have found quite the amount of sentences that meet that requirement of 20 characters or more. Keyword sentence mapping. So this is our flash text keyword processor, so which will be managing all our keywords. So first we load all our keywords into the processor, and in each of the sentences we try to find that keyword, and if it's found, we'll map it to, okay, this is the keyword and this is sentence, that same key value pair matching. So when it's run, the output would ideally look like this: the 18th century, and an array which would contain all the sentences where the keyword exists. This is, I think, one of my favorite part actually of the whole question generation is generating distractors, because we have a word, and ideally, if you're thinking of doing this manually, you will have to think of some alternative words to do, which would be quite easy, I guess. But there are some interesting choices which show up, maybe incorrect, maybe wrong, but it's quite interesting to see what comes up. This is a simple method just to find the position of the token in the overall document. And the get word sense is where our word sense disambiguation is getting resolved. So it first takes in the sentence and the word, because you need context. Because if you just put in the word like bat, we can't really work with that. But if you say, I brought a cricket bat, so now we have context. Now we know it can't be the animal, right? So that sort of context is quite important, and it would find all syn sets. So what a syn set is basically a set of synonyms, kind of, maybe like it's kind of like the word net, I would say. It consists of, okay, so you might have a bat, you might have two different syn sets. So one will contain everything about the animal, and one will contain everything about the object, the cricket bat. So it would have all the hyponyms and the hypernyms underneath that. So by using the similarity option, so there were different options available. It's all in the documentation, but as a default, I've gone with this, which is it's named after each of the research articles. So it's a short and abbreviated form, and it finds the similarity, the syn set using that sort of similarity option. Apart from that, we're also using one of those less algorithms. You can use all the less algorithms and get an average syn set, like the one that's most commonly popping up. But I went with the default, like adapted LESC. And so it'll give us another output. So it says, okay, this is the syn set. And it compares both of those syn sets and gets the closest one. So you may be thinking, okay, why not just get the lowest index? Sometimes it may not be the actual like correct one. Like straight away, why don't we go for index 0? Based on our context, we can't just make those sort of assumptions. We have to actually check it against the sentence. Getting distractors via WordNet. So now that we have our syn set, we'll basically just pass it here, and it'll go through the hypernym, which is our overall topic, and underneath that get all the hypernyms. And if it finds any distractors there, it'll save them in a format of the word and the similarity. And it's the same with the sense to work. We pass our word and our sentence, and it needs to go through like some certain criteria. If the word is a phrase, like in our example we saw natural language processing, that's a phrase with 3 words. So if it contains more than 3 words, then we try and find the whole phrase within our document, and find the top 3 most similar terms to that phrase. If it's just if the word is just one token, one entity, we can find it. Sorry, if it's an entity, then we can that also helps, because you've identified it as an entity, so it'll look for most similar entities. And if it's just a plain word with not an entity, not a phrase greater than 3 words, we can again just straight away pass it here, find its index within the whole document, and find the top 3. Once we do find the top 3, we iterate through it and again save it as the word and how similar it is to our key. This is just to get the label of the word. So if we pass a certain word, they'll return the label. Okay, is it an organization, or is it a geolocation? And this is a method to go through all the entities within our document. And if our word in this case, our key was Sri Lanka, it'll go through all the GPE labels, so geopolitical entity, as I assume. It'll go through all of them and it'll find those similar label entities and it'll say, okay, these are some good distractors. And again, it'll save it as the word and how similar this word is to our original key. And this is how like once we run it, first we take preference to first we do word sense and wordnet, then we go to sense to vec and entities as well. So I've labeled it as this, so that's quite a lot here, but the word the first key that we saw was the 18th century. So then it found, and it was known as a date. So it has found all the dates within our text, and those are some viable distractors here. So that's how the entity one works. It couldn't find any sense to vec or wordnet distractors, and if if you check, there are some sense to vec ones as well. That so it really depends on the availability of whether it's there or not. Yes, moving on. So now we have basically everything. We have our keywords, our sentences, and our distractors. So now we just need to format it all together. So we replace the keyword within the original stem. So it won't be that. It's basically a fill in the blank with the MCQs. And we get the best distractors in our list. We include our key as well because it needs to be in the options. And we just randomize it each time. So if we were to look at some of this output, yeah, so we've taken out the 18th century from the original stem, and we've just added our distractors. So you can see that sometimes, okay, this may not make sense because when the situation of Europe in 17 years old, not really ideal. So it would work when it works, I guess. So it's quite here and there. But as you can see, there are some other answers that seem to work quite well. And there are alternative distractors that you can use. So just with a little bit of filtering and a bit more tweaking, this would work really well for you. And that's basically our final output. So I'll quickly switch back to the slides. Yes. Yes. So as I said, your mileage may vary because there are different parameters that we can change and tweak. Um, there's the summarization criteria, which will include more content or less content depending on how much you're actually summarizing. And depending on the different keyword extraction models that you use, you can get a different set of keywords and they'll be ranked differently. They might say, okay, this keyword is actually the best keyword to use. As I said, spaCy, there are different language models. So using a large model will yield better results ideally, but at the cost of resources. And word sense disambiguation, there were different ways we could have handled it, different less algorithms, different similarity options. So that also can change our results by quite a lot. And this is just a small comparison of those different models and how differently they've provided the keywords and how differently they've ranked it. And yes, if you're looking to dive in deeper with question generation specifically, this is just like a small just some small recommendation from me. I found that these articles by Mr. Ramshri Gautam have been quite helpful. He has a great blog. He goes quite deep into this using transformers as well, so it's more complex NLP at work, and he's generating different types of questions as well. He does have a demo on his site that you can check out, and you can see exactly how well it does work. Um, yeah, speaking of questions, I guess I'll open to answering some myself. Yeah, if any questions are there, maybe you can raise your hand or put it in the chat. Yeah, I guess while maybe y'all are thinking of some questions, I can give some of my personal experience working with question generation. So I worked on it in my final year project because I was quite keen on e-learning, and basically, as I know, final year projects are usually graded on two scales of complexity and uniqueness. So I wasn't too sure about complexity myself, so I tried to go with more of a unique approach. And how I did that was I thought of trying something different with the inputs and the outputs, and the process was quite similar to what you all saw in this session. So that was basically extracting text content from a PDF and then starting the same process, and towards the end wrapping it in a sort of HTML package which can easily be served to some sort of LMS like Moodle or Blackboard. So I think, yeah, that's where that's basically what I did on a twist of this sort of question generation. And if you're looking into complexity, I think it would be more into the process of how you do it. Maybe try and go with a deep learning approach, try and use some sort of transformers like I think T5, GPT-3. I actually haven't gotten some hands-on experience with it myself, but as I've seen, the results are quite good because it takes a look at existing questions and tries to replicate that um, itself. Yeah, if there are any questions, I will be more than happy to answer them. Yeah, I think that's it. But if you do have any questions later on, please feel free to get in touch. And yeah, we'll be. Could you explain those LESC algorithms? Yeah, I actually haven't dived in like deep into it, to be honest. But it's like something of a neighborhood approach, as I know, and it's like, if I try to explain this like as I understand it, kind of like a 5-year-old, I'd say, because I haven't really dived into it. Um, we'll have words which are like used in like a certain context quite often. So the word king might be quite commonly used with the word queen, and so we tend to associate these in the same neighborhood. So the LESC algorithm would um, look at similarities, and I think, yeah, the one I understood most clearly was simple LESC, which looked at the definitions. So if you think of the words king and queen, they might, in the dictionary definition or some sort of definition, they might have the word monarchy in it. So that sort of relationship is then created because of the similarity of the definition. So there can be certain the different sort of similarity, like cosine similarity, which again I'm not too sure. I haven't delved in that deep into it, but yeah, it's basically similarity of words used closely together. I'm quite sorry that I couldn't like answer it in the most proper manner, but I will look into it and I will try and get back to you. Yeah, if there are any questions which I'll try to answer to the best of my ability, yeah, please go ahead. Were there any resources you used when getting started? Uh, yeah, with NLP in general, I use DataCamp, and that got me quite familiar with the different processes of natural language processing, the very simple ones, lemmatization and parts of speech tagging, tokenization. So those, just to get an understanding, DataCamp helped me quite a lot. And regarding question generation, there were some research papers which helped me understand what the whole domain of question generation is. There were some great surveys done comparing different systems. I can share those as well when we share the other resources. Any other resources that were there? The main one I would say was Rumtree's articles. He kept it quite simple and it's practical. there's very little AI, and he works quite well with it. So practical AI, I think, is what he's coined his articles, and I think they're a great piece to look at. Yes. If I do find any other resources that I did use and I must have forgotten, again, I'll make sure to pack it all up and send it to you. Yeah, no problem, Ryan. Um, yeah. Also, if maybe you all don't have any questions, and if you all have worked with question generation before, I'll be more than happy to hear your experience with it. I'm pretty sure there's some there'll probably be some great stories. If not, yeah, again, feel free to get in touch with me after this. I get it. Some might be quite like nervous or shy. Like I think I hope I didn't show it, but I was a bit nervous or shy, but it's all good. Yeah. You can feel free to get in touch with us if there aren't any questions, Fia.